Hello, this is John from TC Math Academy, and in this particular video, we're going to be working with logarithms, and the objective is to write this logarithmic expression as a single logarithm. Okay, now kind of the directions here to write this log expression as a single logarithm is oftentimes referred to condensing the log expression. Okay, so this is stuff that you would learn like in Algebra 2, college algebra, certainly pre-calculus. Anytime you start studying logarithms, you're going to have to be able to do problems like this. This is not that difficult, but I'm not going to give you any hints here because I want to give you a full opportunity to get this right. So if you could do this, go ahead and put your answer into the comment section. I'm going to show you the correct answer in just 1 second. Then I'm going to show you exactly how easy it is to solve this problem. Also, if you need math help with the course you're taking, test prep or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so again, we have log t plus 6 log s. What is this equal to? How can we rewrite this as a single logarithm, i.e., we want to condense this log expression? Let's go and take a look at the answer right now. The answer is the following, okay? Log t times s to the 6th power, okay? So this is the correct answer. Now, how did you do? Okay, if you got this right, that's very impressive. Let's go ahead and give you a nice little happy face, an A plus, a 100%, and multiple stars so you can tell your friends and family that indeed you understand the property or properties of logarithms. Okay, so when you're studying logarithms, you need to understand the properties of logarithms, and it's essential that you know how to write logarithmic expressions. So let's say we have a big logarithmic expression. You want to write that as a single logarithm. Okay, so when you're going from something big to something small, like what we are doing in this particular problem, this act is called, or what we're doing here is called condensing. All right. Now, not all textbooks or teachers will refer to it that way, but that's a pretty common term. Now, the reverse is when we have a single log expression like this, we can do the reverse of condensing, which is referred to as expanding. Okay, so if you're told to expand a log expression like this, we would rewrite it like so. Okay, so basically, in order to go from one expression to another, okay, a big to a small or a small to a big, you're going to need to know the properties of logarithms. So let's go and take a look at the problem here. Now, I'm not going to cover all the properties of logarithms that you need to know. We're just going to take a look at the properties that we need for this particular problem. Okay, so here we have log t plus 6 log s. Now, the first thing we want to observe here, this is really important, that both of these log expressions have the same base. So we're dealing with the common logarithm, log base 10, right? Now, log base 10, we don't write the 10 generally. So if, in other words, if you had like log base 7, you would write that little subscript 7 down there as the base. But when we're dealing with the common logarithm, log like this, it's implied that that is log base 10. So the first thing we want to observe is that these are both common logs. So in other words, if this was log base 7 and this was log base 9, well, we're kind of stuck. Okay, so the properties of logarithms, at least the ones we need to use for this particular problem, the logs, okay, the logarithms, these expressions have to be the same base. All right, so that's the first thing we want to observe. And now, because these logarithms here are the same base, then we can easily combine these. So let's take a look at the two properties of logarithms. Now, again, there's more. And if you want to know more about logarithms, or you need really like full instruction on this, check out like my Algebra 2 course or my pre-calculus course. I'll teach you everything that you need to know about logarithms and exponential functions, etc., etc. But these are two of the properties of logarithms that we're going to be using for this particular problem. Again, there are more properties that you need to know. So the first is log, or this is the product property. of logarithms. So if we have a product x times y, log x times y, or anything times it's something else like so, well, what we can do is we can write this as log x plus log y. Okay. Now, when you look at this, this property works this way. If we have a product, we can write it as the sum of the factors, or we can go this way, right? So here, if I'm moving in this direction, what am I doing? I'm expanding. If I'm moving in this direction, I'm condensing, okay? So this is, you're going to have to kind of think of these properties as, it all depends upon which direction you're moving in, right? It's not always just the product you can expand. It's, in this case, we want to be thinking about, oh, we have log x plus log y. This derived from this product, okay? All right, so this is the first property we need to know. And the second property is log of a power. So log of x to the nth power. You could take this exponent and drop it right in front of the log n log x. Okay, so this is what this is equivalent to. And these are very, very important properties of logarithms, especially this one here. Well, they're all important, okay? But this one here is used all the time, especially when you're solving exponential equations. All right, so hopefully you're familiar with these properties, and again, these are the only two that we need to know. Now, if you didn't know these properties, now you know, right? So here they are. You might want to write these down and see if you can kind of, condense this expression into a single logarithm, right? Of course, I gave you the answer. There's the answer there. But if you're like, okay, you know what, I think I could do this, you should always try to pause the videos. This is my best recommendation to you. The best way to learn math is to try to do the math, solve these math problems on your own. As soon as you feel like you can do it, you should, do a problem. You should pause and, actually attempt it, right? So again, watching me solve it isn't necessarily the same as you understanding it completely, right? It's a little deceiving sometimes. You're like, oh yeah, I watched this guy, I understand what he did. Well, that doesn't necessarily mean you can do it all on your own. Okay, so let's go ahead and get into condensing this expression. All right, so we have log t plus 6 log s, and then you can kind of, the best way to do this, in my opinion, is you first want to take care of any power situations. So here we have 6 log s. This 6, okay, we can put right up here to this s base. Okay, so we have the variable s. I can just take this 6 and scoot this up here. So I'm going to suggest that the first thing you do when you're condensing expressions is to deal with any powers. All right, so if you see coefficients in front of these log expressions, just move those coefficients up as exponents. Right, so what we're going to be thinking about is this property of logarithms right here. Right, so log x to the n is equal to n log x. Or we can just reverse this, right? N log x is equal to log x to the n. Okay, so one is equal to another. So we're just going to scoot this 6 up there, okay, as the exponent to the base s. So let's go ahead and do that right now. And there you go. So now we have log t plus log s to the 6. And there you go. This is an application of this property of logarithms. All right, so now we're looking at it, we're like, well, can we do anything else? Well, yes, okay. We have addition, so when you're adding logs, you want to be thinking multiplication, right? So we can just simply have these two here as a factors of a product here. So this is going to be pretty straightforward. So log t plus log s to the 6, we want to be thinking about this property of logarithms right here, right? So again, we're going to be going in reverse. So log x plus log y, okay, same base, log base 10, log base 10. So I can just write this as a single logarithm, and we have x times y. So here we'll have t times s to the 6, and that's what this is equal to. Okay, so in terms of level of difficulty, I would say this problem is maybe like a 4 out of 10. Okay, this is not that difficult in terms of the type of problems that you're going to have to be able to condense and expand with logarithmic expressions. So this is critical stuff. You really need to understand this. And if you're kind of shaky on logarithms and exponential functions, so this is an extremely important area of advanced mathematics. So again, if you need additional instruction, check out like my Algebra 2 course, probably like my pre-calculus course. Also, I have additional videos on my YouTube channel that can help you out with all this stuff as well. But if this little video helped you out, don't forget to like and subscribe, as that definitely helps me out. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.